All right, guys, we are pretty much masters at exponents now. By this point, if you're watching this video, that means you've done all the other ones, right? So this is just kind of a review. At first, it seems like that anyways. It's a review of everything, but I'm going to give you some little tips and tricks to make you, just level up one more notch, become even better masters at exponents, okay? So here first, we start off with a review of all the exponent rules that you've learned. First, the product rule. So remember, the product rule says that you can add the exponents, right? So if I have a to the power of m times a to the power of n, that's the same thing as a to the power of m plus n. I can add those exponents. So a good example of that, no one likes to use 7, so I'm going to use 7. If I had 7, whoops, I'm on eraser. If I had 7 raised to the power of 16, and I'm multiplying that by 7 raised to the power of 12. I don't have to expand all those out. I just use the rule, right? 16 plus 12 is 28. So my answer is 7 to the power of 28. Simple example, right? For the quotient rule, we know that when I'm dividing two numbers that have the same base, I can just subtract their exponents, which is what it's saying there in letters. Let's do this in numbers. Let's make things a little bit easier here. So I've got, should I use 7s again? Nah, let's use 8s. So if I have 8 to the power of 32, who wants to write that out? And I'm dividing it by 8 to the power of 7. Okay, I don't have to actually expand all those. I can follow the rule, which says these have the same base, just subtract their exponents. 32 minus 7 is 25. My answer is 8 to the power of 25, right? Would have been super tedious to write all those out. We don't have to do that. For the power rule, we know that I have a power raised to another power or an exponent raised to another exponent. I can just multiply the exponents together. So they have it there with letters for us, a to the power of m, all being raised to the power of n. Well, we don't have to expand all that. This time let's use 9s. Let's just keep going. 7s and 8s and now 9. So I've got 9 to the power of, let's do 10. And all of that's being raised to the power of 6. No one wants to write that out. 9 to the power of 10, 6 times? No. We follow the rule. Just multiply the exponents. 10 times 6 is 60. It's just 9 to the power of 60. It's a funny looking 9. All right. You also learned about the 0 exponent rule, which just says anything to the 0 power, or the power of 0, equals 1, right? So they have a letter, but really that's pretty sufficient. It doesn't matter what is being raised to the power of 0. It's going to equal 1. So let's just do, a negative 17 raised to the power of 0. Doesn't matter that it's negative 17 being raised to the power of 0. The answer is still 1, not negative 1. It's 1, okay? Any number raised to the power of 0 is 1. And then finally, the negative exponent rules. Little reminder here, make the exponent happy. I like that. It says just move it across the fraction bar, make it positive. Okay, so if it's on the top, you move it to the bottom. If it's on the bottom, you move it to the top. We'll do one of each. If I have 8 raised to the power of negative 6, and that's it. To make that positive, you move it to the other side of the fraction bar. And I know you're like, well, that's not even a fraction. What do you mean move it to the other side of the fraction bar? I can make anything a fraction by putting it over 1, right? If I move that to the other side of the fraction bar, it's 1 over 8 to the power of 6. And that's what makes the exponent happy. You just take the reciprocal, okay? Same thing if I have the negative exponent on the bottom. Let's say it already is part of a fraction. If I had 1 over 7 to the negative 5th, right? Now it is part. That's easy to see. You just move it to the other side of the fraction bar. Now it's on top. 7 to the power of positive 5. And because there is no other number down there, you can write it as a fraction if you want. You can put it over 1 if you want, but it's not going to change the value of it. Okay. Now we get to the stuff where you guys get to level up a little bit. So for this, whoops, I was trying to scroll on the wrong thing. For this, it says, what if the bases don't match? How am I supposed to apply these rules when these bases don't match? And this is the exciting part. This is the stuff that gets your math teachers excited. Okay. If I have 3 squared times 9, okay, can't do anything. The bases don't match. But look, here's a base that would get us this number, right? I can use 3 as a base and a number of exponents to get it to equal 9. And in fact, it's already being used. 3 squared is 9. So really what I could do is keep the first number the same, 3 squared, times, and change that 9 so that it has the same base, 3, and think, well, what do I have to raise 3 to the power of to get it to equal? Oh, yeah, it's 2. Now it's just 3 squared times 3 squared, right? And we can apply our product rule that says when I'm multiplying 2 numbers together that have the same base, just add their exponents. 2 plus 2 is 4. So it's 3 to the power of 4, right? So look for numbers that do go into these numbers that don't have the same base, right? And just to point this out here, I'm going to put that in. That's really 9 to the power of 1, right? If a number doesn't have an exponent, that means just raised to the power of 1. I just wanted to point that out, okay? For example number 2, same idea. These don't have the same base. I can't apply the quotient rule because they don't have the same base, right? But this top base is 4. This bottom base is 16. 4 squared equals 16. So really what I can do, let me erase those circles, I can keep the top one the same, keep it as a base of 4. I can rewrite 16, this base right here, as 4 squared, right? Now it still has to be raised to the power of 2, so I'm just going to put that 2 there. It still has to be raised to the power of 2, but I can rewrite 16 as 4 squared. Now they have the same base, and this is a multi-step simplification. I don't know if that's a word. I can simplify this in multiple steps. There we go. Right? My numerator is already simplified. It's just 4 cubed. But that base, that denominator, the base, is 4 squared squared, right? It's the power of a power. So if it's being raised, I can multiply those exponents. 2 times 2 is 4. This is really 4 to the power of 4. Now, again, use a little thought process here. I've got the bigger exponent on the bottom, which means I know I'm going to put it under 1, and then just subtract those exponents. 4 minus 3 is 1. Do I have to put the 1? Nah. Okay, it's just 1/4. I can erase that. That way we can just see it 1 over 4. Okay? And again, the reason I got that is I subtracted those exponents, right? The last one, I've got 3 different bases. I've got 2, 4, and 8, right? But then I think, oh wait, 2 goes into 4, right? 2 squared is 4. And actually, I can rewrite this 8 with a base of 2 also, because 2 times 2 is 4, times 2 again is 8. So 2 to the power of 3 is 8. I can rewrite all of these, keep the first one the same, 2 cubed with a base of 2 times 2. Now how do I get 2 out of, or how do I use a base of 2 when I'm trying to represent 4? It has to be 2 squared, right? But that has to still be raised to the power of 3. So we just have to be careful that we still include what it's being raised to the power of. And then that 8, I said, can be raised to the power of 3. There's a lot of different ways to simplify this one. I really like this problem. You could see right off the bat that we have the same thing on top that we have on the bottom, right? 2 cubed and 2 cubed. You could say that those cancel each other out and then just simplify the rest of it. That's not the route I'm going to take. I'm going to follow order of operations. We'll get the same answer if that's the way you want to do it. But I'm going to simplify this first, keep everything else the same. So I've got 2 cubed times a power raised to another power. You guys know we can multiply those exponents, right? So when I look at these exponents, 2 times 3 is 6. So this is 2 to the power of, not 3, I just said 6. 6. And the denominator is going to stay the same also, right? 2 cubed. Keep going. Keep simplifying it by now simplifying the numerator, right? This is the product rule. I'm multiplying two numbers together that have the same base. I can add their exponents. 3 plus 6 is 9. And then now, finally, I can apply the quotient rule. The quotient rule says that I can subtract the exponents when I'm dividing numbers that have the same base. 9 minus 3 is 6. So my answer is 2 to the power of 6. So now you are masters at simplifying these expressions that have exponents. Go ahead and turn to the next page and start working on the assignment. And again, as always, if you have any questions, make sure you ask your teacher.